We're going to be doing a demonstration today using Infusion, using disposable bags and flow medias and resin vacuum manifolds with the feed lines. So Steve's going to go ahead. We got it already loaded. We got the laminate schedules in here. Steve's going to hook up the fill line to it. We got the vacuum on it. It's on full vac. We're able to pull, put full vac down on this, which gets all the air out of the part, out of the glass, out of the cores, and it allows the resins to inject into the materials. A lot of reasons why, go into Infusion, there's different ways, light RTM, the reusable bag like silicone and Infusion, you can kind of see bigger parts, which process is good. The VIP process and stuff is for large parts, maybe a lower volume, one a day parts like that, so you can load them up. You get high mechanical properties out of the glass and the lowest weight, possible and stuff doing it this way. Typical Infusion, you have your materials loaded, you got a vacuum on one side, or like this one's a perimeter feed, and your resin feed in the center, and it fills the parts and drags out to the vacuum on the perimeter. I'm going to touch a little bit on some of the other consumable materials and stuff we have on here. We're using an Aerovac product called Infuply 2 as our flow media. In order to create a lighter product and stuff, we don't want to have a lot of flow materials in the part as like a continuous filament mat or a lot of grooves or perfs and cores, anything like that. So we go ahead and use an external flow media, which is the Infuply 2. So we place that over top of the glass, the carbon fiber here, and that's what's going to promote the flow. The resin's going to flow over that Infuply. It's going to go down into the glass and wet that out. We also have the 800G bag on this part. Vac Seal 23 tacky tape on it, to hold it down. It sticks to the molds, but then does allow it to peel off and stuff when you're finished, so it holds it in place.
The face layer and what will be on the back side are both a woven carbon fiber, a twill weave, 198 GSM fabric made with a 3K input. Very high quality, very nice looking fabric that produces a very nice looking part. What most customers and most consumers expect when you talk about a carbon fiber part. What we put behind it is a little more of a technical product and not what most people expect when you talk about carbon fiber. It's a carbon NCF, it's a multi-axle, so it's layers of carbon fiber that have been spread into a tape and then stitched together.
We're using a product and stuff that they call is red. This is used for the vacuum side. It's a spiral wrapped in their permeable membrane here that has a release film on one side, so you're able to peel it off of the part. It slows down the resin flow and allows the vacuum to stay on your part, so you get a good vacuum. The best thing to do with it is to pull it up into your bag, keep it off the part. If you do throw it on the glass and stuff, it will, it kind of defeats the purpose of it, and you'll start getting resin more into your vacuum line. We're also using brown as their feed line. Same type of material that the resin can go through. It's got a membrane on the inside and stuff that helps with the flow, and it also has a spiral wrap on the inside and stuff to promote flow also.
This type of part being infused, we have two products that we like to promote today. First is our Lantor D77 finish mat, and particularly when you're looking to make a really lightweight part, one of the things that you can do is eliminate the skin coat. And finish mat, we can go directly against the gel coat or actually replace the gel coat. If you have a clear gel coat and you want your carbon fiber parts to really sing, the finish mat's an excellent surface material for that as well. Promotes corrosion resistance, improves the cosmetics. Also, when you're trying to make a hard top, we obviously want it to be light. And sandwich is what makes our composites light, right? Composites are already light, sandwich, we make them lighter. We also make them more cost effective because we're allowing the materials, each one, to do what it does best. Carbon works great. It's very, very strong. It's very, very stiff in thin layers. So by adding a core material, we're able to build the part faster make it thicker, and add stiffness without adding weight.
Just wanted to give you a quick overview of what resin we're using in this part today. It's from our RO10 series. I believe RO10GS to be specific. This product is suitable for both RTM and infusion and pretty much any vacuum molded process. A few things to note: very good elongation, low shrink, good cycle times. It is a low viscosity product, so you should be able to reduce your cycle time, your injection time, and get a good cosmetic part straight out of the mold.
Hi, my name's Russ Powers. I'm with ChemTrend. I'm the technical manager for Composites. I might be last here in the presentation, but really you should consider ChemTrend first, because the best thing you can do is put the right mold release on there. Because if you don't have the right mold release, everything they've talked about is for naught. Here we have R&B EZ for RTM molding. It is the workhorse for that. It's good for the resin. It stands for resin and B-side.
So Don, if you can go ahead and start turning us on. All right, so slowly the resin is now coming into the hose system, and it's going to start coming into the center. So now you're going to see it's gone into the brown. It's wet out the whole brown, and you can start seeing the resin start flowing and stuff through the Infuply too. And it's going down through the glass. It's going through the perfs that are in the core. And it's wetting out the laminate and stuff on the bottom side of the cores. So it's going to slowly make its way out this way to the perimeter vacuum. So this shouldn't take very long. Luckily, with the Infuply, it flows real well. We just got to be careful with the pressures and make sure we're not overflowing this. In a normal infusion process, when you're pulling out a bucket, you keep constant vacuum on it. The bag stays tight. It pulls everything into it. So you can see the Infuply has been cut back a little bit from the vacuum. You want to give yourself a resin break there to allow the flow channel on the bottom meet the outside perimeter and stuff. If you attach your vacuum side directly to the flow media, you can race the resin right across, start filling up your vacuum channel, and the bottom side of your laminate may not get wet out. So that's why you create kind of a resin break, turn it back a few inches and stuff from your vacuum line, and that'll slow down. Once this resin comes to here, it'll slow down a little bit, but it will penetrate and will wet out all of that laminate. You can use the innovators to infuse, but all you do is you just open it up and you pour it into a bucket, turn it on, let it pour into a bucket, and then put your vacuum line into the bucket and pull your resin into it.